Welcome students, welcome to my today's class. Today I will talk on velocity versus time graph and as well as the acceleration versus time graph. So as we all know the equation of velocity, which is s over t. Here s means the displacement and t means the time. So there is a graph which is showing the change of velocity according to time. Just imagine that there is a car which is moving on the road and the change of velocity of the car according to time is given there. When the time is 0 to 4, the car has been increased its velocity, and from 4 to 6 seconds the velocity is uniform, and from 6 to 8 seconds the velocity has been decreased. That means for 0 to 4 seconds there is acceleration, and for 4 to 6 seconds there is no acceleration. Why? Because acceleration is the change of velocity according to time. So the equation of acceleration is A is equal to V minus U over time. Here V means the final velocity, U means the initial velocity, and T means the time. That means the acceleration is the change of velocity according to time. According to this equation, we can say for 0 to 4 seconds there is acceleration, and 4 to 6 seconds there is no acceleration as the velocity is uniform, and for 6 to 8 seconds there is acceleration, but it is called the retardation or deceleration. Why? Because the velocity has been decreased. Okay students, though the question will be like this: according to this figure, according to the graph of velocity versus time, you have to draw another graph which is all about the acceleration versus time. That means using this kind of information, we have to draw a graph and another graph which will show the change of acceleration according to time, or acceleration versus time graph. So students, first of all we have to calculate all the accelerations of the parts according to this graph. There are three parts. This is the first part for 0 to 4 seconds. This is the second part for 4 to 6 seconds. And there is another part which is 6 to 8 seconds. So first of all, we have to write like this: for 0 to 2 seconds. We're going to calculate the acceleration for 0 to 2 seconds with using the equation A is equal to V minus U over time, which means velocity means final velocity. For this line, the final velocity is 10 meter per second, and for this line the initial velocity is 0 meter per second, and the time is 4 minus 0, that means 4 seconds. For 0 to 4 seconds means for 4 seconds the acceleration will be like 2.5 meter per second square. So dear students, we have already calculated the acceleration for the first part, which is all about the 0 to 4 seconds. Now it is the time to calculate the acceleration for the 4 to 6 seconds. For 4 to 6 seconds, the equation of acceleration is A is equal to V minus U over time. For 4 to 6 seconds, as you can see, the velocity is uniform. That means the final velocity which indicates this point and the initial velocity is this point, and both of these are of 10 meter per second. That means there is no change of velocity. The final velocity and uniform initial velocity both are of 10 meter per second. So that we have to write like 10 minus 10, and the time t means 6 minus 4, that means 2, and the answer will be 0 meter per second square. So this is all about the second part, and now we will go with the last one, which is for 6 to 8 seconds. For 6 to 8 seconds, again we have to write the equation A is equal to V minus U over time, and for this one the initial velocity is this, which is 10 meter per second, and the final velocity is this, which is 0 meter per second, because for the last one the graph has been started from this line. So this is initial velocity, which is 0 meter per second, and this one is final velocity, which is 0 meter per second. That's why this is deceleration. The decrease of velocity, according to time is called the deceleration. So we can write in place of velocity or final velocity, the velocity is 0, the initial velocity is 10, and the time 8 minus 6, that means 2, and the answer will be minus 5 meter per second square. So students, we have already calculated the accelerations for the 3 parts, so that we have to write like this. For the first part, A1, for the second part, A2, and for the third part, which is A3. Now, it's time to draw the graph according to the informations about the acceleration. The question was like to draw a graph of acceleration versus time. So we have to draw like this. This line represents the acceleration, and this line is for time. The unit of acceleration is meter second inverse 2, and the unit of time is second. And the mentioned time that we have given was 2, 4, 6, and 8. The acceleration that we have found, like plus 2.5, this is 0 acceleration, and here is the distance from the 0 is 2.5, and there is another acceleration which is minus 5. But we have to draw like this. With using the equal distance from O, here is another 2.5, but this is minus 2.5, and with using the equal distance from O to 2.5, we have to draw another point which is minus 5. Okay, and according to these informations, we have to draw like this. For 0 to 4 second, the acceleration was 2.5. That means 2.5 for 0 to 4 second, and for 4 to 6 second the acceleration was 0. That means we have to override this line, and for 6 to 8 second the acceleration was minus 5. So this is the graph which shows the as a graph of acceleration versus time, and this is all about the acceleration versus time graph from by using the velocity versus time graph, and this is very important topic in your lesson. Thank you very much.